In this video, I want to talk about exponents. Before we jump right into exponents, I want to look at something a little more familiar, and that's addition. So here we can see I'm adding 4 threes. 3 plus 3 plus 3 plus 3 is 12. And it's that's kind of an awkward, kind of a cumbersome way to write it. So this is where multiplication comes in. We could we could express this same equation here using multiplication and be a lot less writing. And again, you're familiar with this, right? This 3 times 4 essentially means you're going to write 3 4 times and you're going to multiply. So the 4 tells us exactly how many times 3 or how many 3's are being added, right? And one other thing that's sort of important here is the fact that the numbers being added all have to be the same number, right? In this case, they're all 3's. Well, it turns out, so this is a pretty straightforward relationship between addition and multiplication. Plays out in the multiplication area. So just like we added 4 3's, then this time I want to multiply 4 3's. And again, it's a little bit cumbersome to look at. And just like multiplication offered us a shorter way to write addition, exponents give us a shorter way to write multiplication. And we write it just like this. Now it's kind of similar in terms of its function, right? Exponents, they give us this shorter way of writing some sort of cumbersome multiplication. And the way we say this is we say this 3 to the 4th power. And that 4 is what tells me how many 3's are being multiplied. Just like the 4 over here was, right? This told us how many 3's we were adding. Now when we're talking with exponents, that 4 tells me how many 3's are being multiplied. Yep. And then just like the case was for multiplication, the numbers being added have to be the same number. That applies to exponents as well. So the numbers that are being multiplied up here, all 4 of them are 3's, and that's what allows me to write that using an exponent of 3 to the 4th power. So this kind of, you can see it makes it a little bit shorter to write. I can show you a little more radical example here, a graphic example. What if I was trying to add 8 3's? Yeah, so here I can write it this way, but it's kind of cumbersome and then real repetitious. So again, this is where multiplication comes into play. And instead of writing all those plus signs on all those 3's, I can just write it as 3 times 8, where again, the 8 tells me how many 3's were being added, and that same rule applies where they all have to be 3's, right? If I have 3 plus 3 plus 4 plus 3 plus 3, then multiplication is not going to help me there in the way we're looking at it here. And again, so this is multiplication, helps us, gives us some shortcut to writing addition. A shortcut for writing multiplication are exponents. All right, so again, it's less writing. So this is much more succinct and shorter way to write this whole ugly thing here. So there's 8 3's. They're all being multiplied. And the way I would say this is I would say this is 3 to the 8th power. And again, what that 8 is telling me is that those are the number of 3's that are being multiplied. And look how similar the two syntaxes are, right? This is 3 to the 8th here, and this is 3 times 8. Two things that are different, right? That when we write an exponent, that times symbol, we don't use that. And when we write the 8 here for an exponent, it's a small number, and it's risen above the line, right? It's called a superscript, and it sits up off the line that the 3 is sitting on, right? And again, the same rule applies. The numbers that are being multiplied all have to be the same number. So in this case, they were all 3's. So here you get a little bit better example of how multiplication helps us write less when we're writing a long addition problem, and where exponents give us a similar shortcut to writing a sort of an ugly multiplication problem. A couple of things, we saw 3 to the 4th, we saw 3 to the 8th, we could have 3 to the 50th, or whatever. But these are the ones you should care most about. These are the most common exponents that you'll see. One of them is just like this, where I'm multiplying two numbers, that same number times itself. So this, we would say 6 times 6 is 36, or we could use an exponent here to write that as just 6 to the second power. And since this is one of the most common, there's this particular exponent has its own name, and it's squared. So not only can I say 6 to the second power, I could say 6 squared. So that's what that little 2 is telling me. Similarly, if I'm multiplying the same number 3 times here, 6 times 6 times 6, again, this would be I could write it in exponent form, and I could describe it as 6 to the third power. But just like with squared, this occurs so frequently, and it's so common, that we have a special name for that, is cubed. So when I'm multiplying 2 together here, it's squared. And when I'm multiplying 3 together, it's cubed. All of the rest of them are described in this way: 6 to the third power, the fourth power, 6 to the fifth power. So these are the two most common. You really need to know these guys. One last thing about terminology here. The number that's being multiplied, in this case, this represents 3 squared, right? So this is 3 times 3. That 3 is called the base. And then the number that tells me how many 3's are being multiplied, those are the exponents. So those are the two main sort of pieces of terminology you need to know. The 3 in this case is the base, and the small number is the exponent. All right, your turn. So there's some examples here for you to take a shot at and see if you can figure these guys out. Pause the video for a little bit, go through and do as many of these as you can. When you then resume, I'll show you the answers, and you can see how well you did. If you got any of them wrong, then you can go back and take a look at the video, and you ought to be able to figure out where you went astray. So pause the video, take a look at these, then resume the video and check your work. Done.